Okay. Good morning to one and all. Today we have to talk about the next question. In the last lecture, we talk about particularly the magnetic properties possessed by the transition element, different types of the magnetic properties, paramagnetic, diamagnetic, ferromagnetic. Then we have seen the example also and what will be the magnetic moment for the particular element that we have seen already. Today we have to continue with the next part, that is a colored, that I already explained, but the question is given in your notes. That's why I'm taking again. Just I am sharing the slides. Okay, it is visible. Slide is visible.
Yes, sir.
Okay. Now we have to talk about the different colors exhibited by the transition metal ions and its compound. See, basically in the what we have seen, I very first you have to talk, you have to remember the very basic thing is that the color is due to the electron. And as the number of unpaired electrons are there, as per as that particular number of unpaired electron concern, there will be the different color for that particular compound. Here we have to talk about in the you can see in the lab we have the different that particular vanadium is with us, chromium is with us, manganese, KMnO4 have you seen? Okay, then FeSO4 have you seen? Okay, then chromic acid is there, then you can see the cobalt nitrate is there, nickel sulfate is there. Okay, that these salts, whatever the this transition elements are there, they shows the different color. Have you recognize this color? आपको वहां से कलर पता चल रहे हैं? हेलो.
Yes, sir. Yes, sir.
Okay, no problem. See, scandium and zinc, they shows the colorless. Okay, whereas titanium purple is there. Okay, light green vanadium, chromium is the dark green, manganese is again the pink in color is there, pinkish. Then that yellow or orange somewhat color is there for the iron. You can see the FeSO4 little bit the yellow orange type shade is there. Okay, then for the nickel again the green color is there, copper the blue color is there. Okay, these these are the this particular transition metal ions are there. अभी ये कब possible है? They are in the +2 +3 +4 +5 oxidation state. This particular thing is happening means that Fe gives this color in the +5 oxidation state. Okay, see here most of the transition metals are colored in the solid state or in their solution, unlike the S and P block elements. Color of the substance is due to its property to absorb the light rays. अभी आपको पता है कि लाइट एब्जॉर्ब करना है, राइट? अभी लाइट एब्जॉर्ब करना है तो कौन करने वाला है? दैट विल बी द only the electron will be responsible for the absorption of the light. अभी क्या होता है in the last lecture in the color particular topic we have seen the complementary colors कि एक पर्टिकुलर वेवलेंथ एडसॉर्ब करने के बाद जैसे कि येलो एडसॉर्ब किया और रेड मिलता है या ग्रीन एडसॉर्ब किया ब्लू मिलता है, लाइक दैट. ओके, फॉर एग्जांपल दैट कॉम्प्लीमेंट्री कलर विद गियर दैट वी हैव सीन इन द स्टार फॉर्म. ओके, कि एक कलर एडसॉर्ब करने के बाद एब्सॉर्ब करने के बाद दूसरा जो है वो इमिट करता है. If a substance absorb light of certain wavelength, it will give the complementary color absorbed. Example यहाँ पे दिया hydrated CO2 plus ion absorb wavelength of the red light and transmitted rays of the light causes blue color to the CO2 plus ions. CO2 प्लस आयंस के लिए कौन सा कलर मिलने वाला है? ब्लू. वो आपका जो विजिबल स्पेक्ट्रम है, विजिबल विजन है, उसमें का कौन सा लाइट एब्सॉर्ब करने वाला है? रेड लाइट. Salt of the most of the transition metal and their cations are colored. color can be related to the number of unpaired electrons present in the atoms of the ion. यहाँ पे that I have to show scandium, okay, +1, this is a +2, +3, +4, +5, okay, goes on increasing. ये ट्रेंड जो है यहाँ पे +5 आता है, okay, then again goes on decreasing. फिर ये जिंक का जो है that is in 0, here you can see the +1 like that, +2, okay, this is the +3 like this, nickel 3 plus, okay, having this color, particular uh, green color, vanadium 3 plus green color, nickel 3 plus green color, that you have to remember. Okay. Name the next question is name the important oxides of the titanium and vanadium. Give the properties of the oxides of titanium and vanadium. See, titanium, there are the three oxides. This question is very much different, and this one is very much different. I have taken this part as far as the MCQ is concerned. This is the very most important and abundant element in the earth crust, and it present as oxides in the most igneous rock, in sediments derived from them, in living things and natural bodies of the water. Titanium containing minerals or ores are rutile, ilmenite, perovskite, titanate or spin, and arizonite, out of which only rutile and ilmenite have the economic importance, because 92% of the world supplies are dependent on these ores. TiO2, this Roman 2 is the oxidation state. TiO2, golden yellow crystalline substance, basic oxide and dissolved in the acid. ये basic oxide है और dissolve किस में होता है? Acid में होता है. ये उसकी properties है. Then TiO3, this is the ilmenite, colored and paramagnetic, more basic than Ti4 plus. TiO2 4. Now TiO2 4 occurs with the three crystalline form rutile, antes and brucite. This rutile, again this particular ore is there. Then rutile is the most common red or yellowish crystal, stable at 1040 degrees centigrade and insoluble in water. These are the three basic oxides of the titanium that you have to remember, and their properties are given. You can write your own word. Then oxides of the vanadium. There are the 5 oxides of the vanadium: V2O, then V2O2, okay, then you can see the V2O3, that is in the +3 oxidation state, V2O4, that is the +4, and V2O5 is in the that particular okay. Then first one you can see V2O in the +1 oxidation state, vanadium is in the C. Vanadium suboxide, vanadium dioxide, vanadium trioxide, vanadium tetroxide, and vanadium pentoxide. Okay, these are the 5 different oxides. In that you can see first one is the suboxide is at ordinary temperature forms the brown coating. Existence is doubtful. Existence उसका doubtful है. Then V2O2, that is a +2 में grey powder insoluble in water dissolved in dilute acid gives the violet colored solution. Okay, V2O2 plus O2 gives the V2O4 also. Then vanadium trioxide, black powder slightly soluble in water gives the green solution. It conducts the electricity and basic oxides but not easily attacked by the acid. Then vanadium in the +4, dark blue crystalline powder possesses basic and acidic properties soluble in acids, and when come in contact with oxygen it gives you the pentoxide. Okay, then it is a pentoxide is a poisonous yellowish red powder, melts at 600 degrees centigrade, sparingly soluble in water. Acidic and basic properties they have, used as a catalyst in contact process. सब मतलब ये catalyst करके use किया जाता है preparation of the H2SO4. Then used in photographic plate developers or say photographic developer, you can and use as a medicine also. अब ये कहाँ मिलता है? It is a byproduct found in byproducts of the mining. जब माइनिंग करते हैं उसका बाय प्रोडक्ट में मिलता है. इट इज ऑल्सो ट्रेस एलिमेंट इन मेनी डिफरेंट टाइप्स ऑफ द रॉक. देयर इज ऑल्सो स्मॉल अमाउंट ऑफ वेनेडिएंट फाउंड इन द ह्यूमन बॉडी. इट कैन ऑल्सो बी फाउंड इन द एल्यूमिनियम ओर एंड डिपॉजिट रिच इन कार्बन. ओके, दिस इज अबाउट द वेनेडियम. यहाँ पे आपका जो है दैट पर्टिकुलर फर्स्ट पार्ट, the first part of this particular coordination chemistry is going to, I think so, finish, right? उसमें लास्ट का क्वेश्चन आपका वही था कि केमिस्ट्री ऑफ द टिटेनियम एंड वैनेडियम, प्रॉपर्टीज ऑफ ऑक्साइड्स. ओके, एक क्वेश्चन बाकी है, दैट इज अ क्लोराइड्स एंड लाइक दैट. इफ आई हैव दैट आई कैन टेक इन. Okay, that last question we will see in the next lecture, and then we will stop there. Okay, if you have any problem, any doubt, you are always welcome. You can free to ask during the lecture also. And जब lecture के बीच में भी आप पूछ सकते हैं कि मुझे ये आ नहीं रहा, ये समझ नहीं रहा है. Okay, if you have any problem, any doubt, you can freely ask.